Welcome to the Developments in Data Management at NOAA, NESDIS, and NCEI session. I'm one of your co-chairs, Tyler Christensen. I've been around NOAA doing data management for a number of years, but my background is in marine biology. So next slide, please, John. Okay, so welcome to the session. Just a reminder that by participating in the session, you agree to adhere to the ESIP community participation guidelines. Want to remind everybody that the session is being recorded and will be archived for future viewing. And please stay muted if you're not speaking. I wanted to give this opportunity to for the ESIP team members to, fellows and employees to do a quick introduction. Thank you so much for your support.
I guess I can kick off. Aaron Freeze, Technical Community Director, here in a support capacity. Let me know if you experience any issues. Feel free to reach out. I'll pop it over to Bobby.
Oh boy, hey everyone, Bobby Saba. I'm one of the ESIP community fellows, also here really in a technical capacity, so I look forward to hanging around and listening to all the good stuff today. Maddie.
Thanks, Bobby. Hi everyone, my name is Maddie. I'm also a community fellow. I'm also a PhD student in marine biology currently, so really interested to hear this talk. And yeah, please let me know if you need help, or we'll be keeping an eye on the chat for any questions or links needed.
Okay, perfect. Thank you so much. We'll be using Slido for Q&A, and we'll do a couple of polls during the session. So there's a link to Slido there, or you can use the QR code. So please don't use the chat for asking questions. We'll be using Slido for that. Okay, next slide, please. Okay, so John and I will be doing a quick sort of introduction and context presentation here, and then it'll be followed by two more deep dive looks at a few of the efforts that are underway in NESDIS and NCEI. But in this initial intro, we'll be talking about what is NESDIS, some policy context for the work that we do. And then some information about NCEI, our migration to the cloud, and some background on fair data and open data licensing. Next, please. Okay, so what is NESDIS? NESDIS is the NOAA Satellite and Information Service. It's technically National Environmental Satellite Data and Information Service. So our parent agency is NOAA and the National Oceanic and Atmospheric Administration, and we're an agency that enriches life through science. So we go, our observations go from the surface of the sun to the depths of the ocean, and we're working to keep the public informed of the changing environment around them. And so that's our parent agency, but NESDIS is one of 6 NOAA line offices that includes the National Ocean Service and the National Weather Service. So we're one of those partner line offices. And our main job is to operate the nation's weather satellites. We offer 24/7 support, and this is really critical data to protect lives and property. And so we... In addition to operating the current weather satellites, we acquired the next generation of Earth and space weather satellites. So we're always looking forward to the next generation of satellites to provide continuity in these critical data. So we take those data, we provide them to our main partners and to the public, but we also process those raw data into products to meet specific needs. We also provide definitive assessments of the U.S. and global climate through NCEI. And also through NCEI, we maintain one of the most significant archives of environmental data on Earth. So this is why we call ourselves a satellite and information service, because we operate and plan the next generation of satellites. We make those into information products, but then we also host the main data archive. Next, please. So if we look at NOAA's 2026 data priorities for this year, we're managing NOAA data as strategic assets, enhancing access and usability. This is always a big priority for us. We're doing a really big push this year to support NOAA's cloud modernization, and we're safeguarding NOAA data. So the way that we're doing those things are include Evidence Act implementation. We'll talk about that a little bit in a second. The executive order on gold standard science. So we're making sure that we're meeting the administration's priorities. We're looking at AI as an ongoing priority for us. And as I said, cloud optimization. We're also taking a refreshed look at IQA, that's the Information Quality Act, to make sure that all of the information products, including data that we produce for the public, meet IQA requirements. Next, please. So the data policy context. Our foundational legal authority for opening our data to the public and for much of the data stewardship and data dissemination work that we do is the Foundations for Evidence-Based Policymaking Act. The second title of that, it was called the Open Government Data Act. So this requires things like we need to make all of the data that we collect open by default. So the main thing there is that the American people have already paid for the data that we collect and the observing systems that we use to collect that data through your tax dollars. And so we have a legal obligation to make those data freely available to everyone, including for commercial use under an open data license in non-proprietary formats with metadata and a comprehensive catalog. So taking those sort of fundamental legal requirements from the Open Government Data Act, NOAA has put in place our own policy updated in 2023, which is NAO 212-15B, Management of Environmental Data and Information. So this sort of specifies some of how we're going to implement some of those requirements from the Open Government Data Act. There's also an implementation handbook linked with that NAO that talks about the requirements that are passed on to the NOAA line offices to meet those requirements. So for the short term, we're focusing on a couple of things. So we've got a new focus on persistent identifiers. So that's DOIs, that's RORs to identify entities, but we're also focusing on open data licensing. So NOAA, in the implementation handbook, it specifies that any data that is fully NOAA sourced should be available with a CC0 Creative Commons completely open license. So we're focusing on implementing that open data license for NOAA source products. Next, please. So I'm going to hand over to John. Let me just give a quick introduction to John. So our next speaker is John Ralph, data curator and data archaeologist with NOAA's National Centers for Environmental Information. John is the current ESIP Governance Committee Chair and has been active in ESIP for many, many years. And John works for NCEI and is active in archival data governance. So take it away, John.
Thanks, Tyler. So as Tyler mentioned, we, NOAA, but NESDIS especially, is working really hard to move all pretty much everything into the cloud IT-wise, but especially an emphasis on what NESDIS really does, which is get the data from the satellites, put it through the ground system, put it through product generation, supporting the algorithms to generate the products that Weather Service needs and other partners need. And so we are building the NESDIS Common Cloud Framework, NCCF, which leverages enterprise technologies and processes to build an agile infrastructure architecture with the goal of supporting and accelerating migration into the cloud. And I'm not going to go through this diagram, but suffice to say that there are many components involved. I'm particularly interested in the stewardship service box there, but that's because I'm in the data stewardship division of NCEI. Speaking of NCEI, I wanted to stress our mission, which is to provide environmental data products and services covering the depths of the ocean at the surface of the sun to drive resilience, prosperity, and equity for current and future generations. And I wanted to emphasize that we believe, we hope we will be around for some time to continue to do this. As Tyler mentioned, one of the priorities is to safeguard NOAA data, and that's what NCEI is really focused on. So in that, following on that, we envision ourselves as being NCEI as being a tenacious and trusted leader in environmental information for a rapidly changing world with a focus on driving lasting good across our partnerships, economy, around the US, but around the world as well. Next slide, please. Oh, thanks, John. So back to the cloud, NCEI is building, or has built, and it's continuing to build the Open Information Stewardship Service, OIS, built on NCCF and uses knowledge graphs in a semantically enabled linked open data interoperability framework. And if you want to know more about that, talk to Ryan. To enable full provenance in a scalable, repeatable, and transparent platform. So basically, in the future, OIS will be the workflow, the data workflow manager that we use to archive and steward data in the cloud. Now, we're already archiving and stewarding some data in OIS, but that's part of our migration will be to move more and more of our archival data workflows into the OIS framework. It actually went into production December 2024, and we regularly make enhancements and improvements to OIS as deliverables of our agile release train. And as an aside, that agile release train is not just NCEI; it's in coordination with the large agile train across NESDIS. Going back to what Tyler said about FAIR data and the implementation of our NAO, the NOAA Data Management Handbook, which came out in October 2024, documents the requirements that we have for managing our data and the things that Tyler stressed that we are working on. Archival of all the data supporting referee journal articles, for example, that's something that we have a new focus on. Documentation of the dataset contributors and their affiliations, and the open data license that Tyler mentioned, and of course PIDs, DOIs, ORCID IDs, ROR IDs, and other PIDs as applicable. And documentation of funding sources with a PID if that's available. I think, if I remember rightly, NOAA hasn't quite decided on what PID system they will use for documenting funding sources, but that will be coming shortly to an agency near you. And then collecting metrics on all aspects of our data stewardship. And that's one thing where the PIDs can come in handy, make it a little easier to connect people up with research objects that they're responsible for. But numerous challenges remain, so it's a work in progress. On the open data license note, Tyler mentioned that any data products that we produce using solely NOAA data need to have a CC0 license, And there's specific language that the NOAA Data Management Handbook has for those, as they call them, internal NOAA source data. So in order to improve our ability to document the license that goes with any data set, we updated our send to NCEI tool to to require the data submitter to choose the license that will apply to their data. So if it's a NOAA data set, they can check the internal NOAA source data box, and otherwise they get a choice of CC0 or CC BY 4.0. And then that data license goes through our archival workflow and into the catalog at the other end for discovery and use. So that's pretty much what we had to say in the sort of high-level context of NESDIS and NCEI. Are there any questions? I don't hear any questions. Are there any in the chat? No, I don't see any in the chat.
There's one in the Slido Q&A. How are data licenses being applied to historical, e.g. already in the archive data sets?
That's an excellent question. And the answer is, in general, they are not, because unless we can get the original producer of the data to tell us which license should apply, we can't really, well, that is to say, we have not yet decided to take sort of global action on all historical data. I think at some point we may decide to do that, but at the moment we are not.
We've got a couple more. I'll just keep asking them. What does internal NOAA source data mean?
I can take this one. This is internal NOAA source data. That means all of the data that go into that product are from NOAA observing systems, or collected by NOAA people or observing systems. So we collected the data. We've processed it according to NOAA produced algorithms. So all the intellectual property basically also belongs to NOAA, and it's disseminated through a NOAA system. So, I mean, a classic thing is the GOES imagery, that is a NOAA platform. It's processed by NOAA algorithms. It's disseminated through NOAA systems. So that should get the CC0 license. So there's a lot of gray areas, and we don't. We're starting just with the very clear ones, where there's no gray areas. This is very clearly only NOAA source.
And there's a question from Andrew in the chat: why CC0 and not PDM for NOAA source data? And that's a really good question. I actually wasn't aware of the PDM and the fact that it's basically superseding the CC0. That may be something that changes with the projected update of the NOAA Data Management Handbook that we're expecting. I don't remember the schedule, Tyler, but it's soon, we hear. At which point then we will add that if that's what we are directed to do. But that's a really good point. Thank you very much.
Yeah, I was just coming at it because my understanding of government works is that they're not copyrightable at all in the U.S. And that would imply like it's public domain and not dedicated to the public domain, which implies that there is a copyright holder. This is really weedy, but I was just wondering. So never mind.
No, that makes sense, and I see why they've created that particular mark. for those situations. But at the time when the NOAA Data Management Handbook came out, I'm not sure there was the PDM. Interesting question, though. Thank you.
I guess on a related note, we have another question in Slido. Is there guidance on when to use CC0 versus CC BY?
It's really whether you wish to essentially ask people to cite the work whenever it is used. And the CC BY basically says you must attribute the work. CC0 is a little vaguer about that as far as I'm concerned. But of course, we'd still like that for everything. And that's why we are putting DOIs on our data sets and such. But I think also there seems to be a preference difference between the United States and Europe. And Europe seems to want to use a CC BY more often. But I suggest read the documentation and choose the one that makes the most sense for you.
Okay, we've got, I'm sorry.
No.
Okay.
Thanks, Peng. Peng says in chat, the CC BY also indicates that the copyright holder retains the copyright, which that goes back to what Andrew said, that technically government works are not copyrightable. So what does that mean in terms of, yeah.
Okay. Another question we have, can you share any more information about the metadata / knowledge graph work you touched on?
The knowledge graph represents or connects, I should say, not just the metadata and documentation, but also all of the objects that make up the data set itself. So all of the files or any other artifacts of the data set. So one can follow the knowledge graph to find out the documentation about a data set, but one can also follow the knowledge graph to find all of those data files. And in fact, the knowledge graph connects all of the objects in the archive in a way that is searchable and traversable.
Thanks. That was me who had that question. Is there any documentation or places where I can learn more about that off the call? Thanks.
I think there is, but I don't have it to hand.
Cool.
I think there is some documentation available on the web to the outside world. I know I did a Google AI search and said, tell me about OS, and it did a pretty good summary. But I did not ask for details on the knowledge graph, so I'm not sure. But I know there is documentation available. I'm just not sure where it is. Is your name in the?
Yeah, Corey Levinson from Submarine Scientific.
Right. I just wanted to make sure it was in the minutes so we could remember to let you know if.
Yes, I put my name in the meeting notes. Yeah.
Excellent. Thank you.
Cool.
Ken Casey of NCEI stresses that the knowledge graph also stores the workflows as well as the results of every step of the workflow, so that the process as data is part of that knowledge graph implementation or vision or whatever you want to call it.
Okay.
All right. Well, we should probably move on to our next presenter. And our next presenter is Inger Kittel of NESDIS, and she's the Data Implementation Lead for the NESDIS Office of Common Services Product Implementation Branch. Inger spent 15 years as a littoral oceanographer working on multiple maritime and data governance committees for the DoD before coming to NOAA in 2024. She has an MBA from Western Governors University and a BS in Geography from University of Southern Mississippi. Inger, I'll get your presentation up.
Thanks, John.
And you can begin as soon as I do that.
All right. Thanks, everybody, for tuning in. John gave a really nice overview of what the NESDIS Common Cloud Framework is. I'm going to dig a little deeper into that and explain how we utilize the framework to do a migration for the IU's High Frequency Radar Network project. Next slide, please. This one's just a little bit of guide of what I'm going to be talking about today, so I'm not going to worry about that. Next slide. All right, so what do I mean when I say that we did the migration for this? So this project, basically I started in 2024 in March, and this project was the first project that came across my desk. So I served as the federal project manager for the implementation of the IU's High Frequency Radar Network, or HFRNet, migration from Scripps Cord-C Institute to the NESDIS Common Cloud Framework, or NCCF as we commonly call it. What that meant was a little bit daunting. We basically had to take data from approximately 183 coastal radar network stations. Those are both continental as well as in the Caribbean around Puerto Rico and the Virgin Islands, and then the Pacific around Hawaii. Take the SQL database and the portal node structure that Scripps had used previously, convert that into one database. Also do some work under the hood on the algorithmic part to convert that from MATLAB to Python, and then disseminate that data back out to both the Weather Service, National Weather Service, and to IUS so that they could host the data on a portal. Now, this data is utilized in many applications for surface current, speeds, directions, wave heights, anything from marine navigation to disaster response for oil spills and things. But one of the most important implications of it is for U.S. Coast Guard search and rescue. So we were given basically a year to get this migration done and to make sure, because it is a high stakes operation for Coast Guard support, we needed to make sure that we could get the outage times as low as possible, because clearly they need that operating 24/7. So our current status on this project is over on the right-hand side. I'm pleased to say we were able to get the database operational by the time that Cord-C needed to wind down, which was July of 2025. We're currently doing operations from our user acceptance testing environment, UAT, but we are in the process of monitoring that and testing to move our migration efforts to a full production environment where our operations center can do our 24/7 monitoring. Next slide, please. As I said, John already gave a good overview of the NCCF, but I'm going to focus on 4 of our 5 core services. We have the 5 are secure ingest service, sandbox, product generation, archive and stewardship, and then dissemination and access service. For the purposes of this brief and my limited time, I am not going to talk about the archive and stewardship piece. Due to the limited time we had to implement this project, that piece was decided that we would leave that for a secondary phase of the project migration, hopefully in the next year or so. But I will concentrate on the 4 services that we did utilize for our end-to-end proper migration. And then we do have 2 services that are also listed on the bottom as our secondary services of storage and metadata cataloging, which I'll also talk about just very briefly. Next slide. So this is an overview of those 4 services that I listed. Now, all of these services, if not operational at the time that we got this project, were quickly rushed into operations in support of this project in particular. Not only was this project important for being one of our first test cases for an end-to-end operation, but this also, because it's cross-line office support, it's one of the first non-satellite projects that we had. There was a lot of configuring and a lot of getting into the really nitty-gritty of the details for, metadata standards and things that we did to help refine the data sets as they were coming in here. So I'll talk a little bit about that as I come on and go through an overview of each of the services. Next slide, please. So starting with the first one, secure ingest. Our secure ingest service uses a push-pull operation and can, for testing purposes, can take a variety of security levels down to FTP if we're only using it in our development environment. But if we're doing anything that needs to go out on our FSMA high boundary or be directly disseminated to a customer, obviously we have to use a more secure model. They do this through a host of pipelines that we monitor in GitLab. Next slide, please. And we connect these to our data dashboards and alarms. This was probably the most tricky portion of setting up this project in the NCCF. As I said originally, we had about 183 stations we needed to connect with. Those stations were organized along different ways. Some connect straight to the main portal. Some of them go through a server and then, which is aggregated at a university and then connect to us. So we needed some way to kind of define all of these stations in a way that made sense to our engineers and developers that were working on this project. My assistant project manager and I came up with this schema of listing everything by the 11 IUS regional associations and then digging in via fishbone diagrams. Next slide, please. To detail exactly how those stations would be connecting into the NCCF. This proved immensely helpful in helping categorize the data and also providing really clear diagramming for security purposes so that we can get all of the necessary network approvals. Next slide. The last portion of ingest is the dashboards and alarms that we have set to tell us when any data sets are out. As I stated, we have some of this data that's coming as an aggregated load from servers. So this is just an overview of what it looks like for one area when we're getting our data loads in. And you can see at the bottom, they kind of break it down by the networks that we're receiving data from. Next slide. Ooh, the one animation I threw in here. Or we can slice and dice the data in different ways to show not only the amount of data we're getting, who we're getting it from, any of those sort of things, so that we can really dig in the details if we have any issues with data outages or lower data frequencies from certain stations. Next slide. Our Science Sandbox service. This is one we didn't utilize in detail for the HFRNet project just because we didn't have an actual science team working on the code. The code was already delivered to us, so our developers worked on the code directly. But our Science Sandbox is an environment where any team that is interested in migrating to the cloud can come and work on their own algorithms and code in a relatively secure environment while still connecting to all of our services. And if they get to a point where they decide that they need to disseminate this data or move it up into a higher controlled environment, we have extensive CI/CD pipelines where they can do that. Next slide. As I said, we didn't have a sandbox team working at the time, but we did utilize the sandbox in order to pass the database and the code back and forth between the two teams that were working on each of the pieces. So we were able to go through all of the security scanning that's necessary to do all of the promotions that we needed in order to get this project to operations. Next slide. Dissemination. So our dissemination service is built off of a legacy on-prem system that was only able to push data to two S3 buckets. But I'm pleased to say that through using this project in particular as a guinea pig, among a couple of other ones, we were able to get full promotion for our subscription fulfillment service to our production environment. So they can do push or pull for customer sets, and they have enhanced metadata functionality so that they can provide all the necessary metadata for the IUSE HFRNet portal and for the archive package that the Weather Service is so graciously putting together for us right now until we get to the phase 2 implementation. Next slide. However, in order to do that dissemination service, we needed to define down exactly what each customer wanted. While the service is a common service for all teams to utilize, it does allow some niche customization in what product deliveries they want from the data set. So you can see by the data flow table on the right, we did a lot of editing as to this customer gets this customer gets that. And as far as I am aware, everybody has been pleased with their deliveries to date. Next slide. And then just to recap, this is a little bit of an overview of some of the capabilities and improvements that we made for the initial transference for HFRNet. From connecting to an individual server to developing the fishbone diagrams to delineate the server access. We also worked with one of the universities to update their security protocols so that the system would be fully SFTP. We are doing project monitoring right now on an 8x5 schedule. So 8 hours a day, 5 days a week, but we do have systems and alarms put in place so that when we go to full production environment, there will be the availability of 24/7 monitoring. And next slide. So what's next for us? As I said, we're working on doing the promotion to full production. Last I heard that we're going through the testing phases right now, but we expect that to be done by like the first week of March or so if there's no more critical weather days or anything that will hold up doing our operation testing from prod. We have email chains set up for the station operators as well as the IUSE Surface Currents Program Manager so that they know when there are any outages or issues. And we have established a process to work any new stations or major station changes into our agile framework structure for development and processing. And then the next piece that I am excited about for phase 2 is working on getting the archive piece in. So that will be the next one we work with NCEI on. And then eventually we are going to look at involving the Canadian and Mexican stations that are also along the coast and part of this network. But because that requires certain international permissions and things, that may be coming along in a later phase. All right, next slide. And this is my last one. It's just a kind of recap of everything I talked about as far as what we did for enhancing the project, what the project is, and what it supports. So last slide. Pending any questions, that is all I have.
Excellent. Thank you, Inger. Andrew, go ahead.
Yeah, so I was wondering, like, are you in like just one cloud provider, or like, because AWS has had some, as an example, has had some high profile outages over the last year and whatnot. So I'm like wondering what your what's your resilience strategy when it comes to like the actual cloud provider itself?
That's a great question. So we are on AWS, and there is some planning currently in the works as far as developing a structured resiliency plan and backup operation system. Right now, we have a few measures that were put into place with services like our ingest and dissemination service, where they can replay the data. So they capture any data that was taken for up to 7 days, I believe. We can handle an outage up to 7 days, and then they will re-ingest that data for us. So we've already utilized that a couple of times when we've had recent system quirks to make sure that we filled any data gaps that had arisen. But there is a plan in the works for a longer term resiliency strategy.
Thank you. Yeah, it's interesting how to deal with that.
Are there any questions in the Slido?
We have a few questions, I think, lingering from the introductory talk. I don't see.
Yeah, if there's no other questions for Inger, then we can talk about those other questions when we reach the end of all the presentations. All right. Well, seeing none and hearing none, I will get the next presentation up. If I can find it, of course.
Oh, I've got it. Yeah, I can share on my screen.
Oh, if you wish, then that will be
for you.
Oh, look at that. There it is. Thank you. But before you start, I will say our next speaker, Kristen, you're starting, right? So our next speaker is Kristen Sabi, Scientific Data Manager at NCEI. I work with her quite closely these days. Kristen has a background in quantitative ecology, and prior to joining NCEI in April 2025, she facilitated data management activities at Flora Fish and Wildlife Conservation Commission. She holds a PhD in biology from University of Florida. Kristen, are you going to introduce Anna?
Since you have it pulled up, do you mind introducing Anna?
In that case, I will introduce our other IU's data manager, Anna Krelling. She's the technical data manager for IU's data here at NCEI. She has a background in physical oceanography and joined NCEI in March 2025 after working for a few years in academia and industry. She holds a PhD in marine science and technology from University of Massachusetts and in oceanography from University of Sao Paulo. I particularly like the University of Massachusetts Dartmouth because it's really near one of my vacation homes. Yeah, one of my vacations. All right. Well, thank you. And Kristen, take it away.
Thanks, John. Yeah, so Anna and I would like to introduce you to some of the work that we've been doing at NCEI, working to facilitate archiving, integration, ocean observing system data. Oops. Yeah, so similar to the data that Inger talked about, we are archiving integrated ocean observing system data, but we'll focus more on different data sets than the HFRNet data that Inger talked about. So, and we'll dive a little bit into some of the specifics of IUS. And so IUS is a community of non-federal partners organized into 11 regional associations across the country. And they collect many types of observing data. So the data that we work with is mostly oceanographic and meteorological data from buoys. Like we just saw, there's also data assembly centers that are part of the IUS network. So the HFR, the High Frequency Radar Data Assembly Center, and then we also have underwater glider data, and then marine animal data, marine animals that are tagged with satellite receivers. That data is also archived via a data assembly center. So NOAA mandates the archiving of IUS data at NCEI so that it can be used by future generations. Because the collection and archiving of many data sets is ongoing, we have automations set up to accomplish this, which of course would not have been possible without much of the work that John has done. So we're forever grateful to be able to work with him. But let us walk you through some of the basics. So we have code scripts that are running on a schedule, and these basically download new and or updated data from the data provider, and we run some quality control on the data and the metadata. And if we detect no errors in those quality control checks, we'll archive the data and then notify relevant individuals. And conversely, if we do detect errors, we do not archive the data, and then we notify relevant individuals. In some cases, the same as get notified about successful archives, and then sometimes additional people. And an example might be invalid standard CF names. Somebody just kind of made a CF name up, and it's not valid. So we won't archive that data. And these are IU's dataset archival automations have actually been running for a while now. The Great Lakes Observing System automation began archiving in 2014, and all of the other automations for the other 10 regional associations were up and running, I think by about mid-2017. So they've been running for about a decade so far. I've mentioned automations a couple of times, but we want to be clear that these automations do still require, humans in the process. So some human oversight and intervention. Often they need to be updated because of changes in data management practices, changes in IT infrastructure, not just on the side of, let's say, the data provider, but also NCEI. Then we have staff turnover or changes in points of contact. And then I guess more specifically about IT infrastructure, we take advantage of technological advances, which might mean we'll need to update these automations. And partly because of this, the volume of IU's archiving work has led to a backlog of years of work to tackle. And so that is basically where we come in. So we're funded through an Inflation Reduction Act grant. We both started in early 2025. Kind of hard to believe that it hasn't even really been a year yet. It feels longer and shorter than that. But we have spent a lot of time focusing on evaluating and providing guidance to these regional associations. And we've been working closely with two federal colleagues in particular, Heather McCullough, a physical scientist, and then John Ralph, who's helping to chair this session. But of course, many other NCEI and NOAA colleagues are important to help us accomplish our work. So we've been focusing a lot on evaluating, providing guidance on metadata because this quality metadata means that the data can be used and understood well into the future by current and future generations. And so some of the work that we do, we investigate and resolve issues related to metadata so that we can get those quality control checks to pass and we can archive the data. And at this point, let me hand over the presentation to Anna, who's going to walk us through some examples of the actual work that we do with this data.
Well, hello, everybody. Thank you again for attending this session. And as Kristen alluded to, we've had our hands full ever since we got to NCEI, and it's been fun. So I'm going to get to some examples of what we've been doing since, I don't know, maybe mid last year. Kristen mentioned quite a bit that we deal a lot with metadata, right? So one of the things that we do is we curate tables with standardized spelling of metadata items for NCEI to display on public data access pages. So what happens is we receive sometimes as part of the same data set, different data files that have different spellings that refer to the same institution in this particular example. So in the table that you can see on the screen, we have on the left 3 different spellings that refer to Dauphin Island Sea Lab. So what we do is we map all the different spellings to the same standardized spelling, right? And what happens as a result is that on the landing page, which is what we call the web page where you can get access to the data and also information about it, so much of the metadata. So what happens is that you can see on the collecting institutions, you're just going to see what the standard spelling of that institution. So you're not going to see all different spellings from all different files, right? And besides that, another thing that happens is that when we go to the ISO file with all the information about this collection or this accession, we can find the ROR, so the persistent identifier for that particular institution. So that's very helpful because it surely enhances findability. So yeah, that is one of the things that we do. So once in a while we have a new different spelling and then the system says, hey, I don't know which institution this is. And then we just need to make sure that it's not a repeated institution. It's not a different spelling of an institution that we already have data from. Next, please. So this example is about institutions. We have something very similar happening to people, to creators and collaborators. So we have, for example, different data files that have the same creator or collaborator, but that person's name is spelled differently in different instances. So again, we map to a standard spelling, and we map that to the ORCID ID for that person. So again, enhances findability. Next, please. And then this is a whole other situation. So we try to make sure that the platform and instrument are well documented in the metadata. And this can get tricky, right? Even if you have just one instrument in each platform. So let's say for each data file, you're talking about one platform and one instrument. It is sometimes tricky to get that information. Sometimes the data providers, especially for older files, they don't have the full information that would be ideal to have. But even for recent ones, that does happen. And again, ideally, we would want the full information. Make a model and everything, calibration date, if possible. That'd be amazing. So to complicate things a little bit more, sometimes we have a platform with multiple instruments. And as an example, in this image, you have an instance in which the same buoy actually collects sea surface temperature, collects nitrate, and collects chlorophyll. So you may have different instruments collecting different variables. Next. So if it's not super easy to get that information for one instrument and one platform, that becomes a lot trickier when you're dealing with multiple instruments for one platform. The guidance on that, sometimes it's not very clear. And again, as Kristen mentioned, we're dealing with 11 RAs, 3 DACs. So it's quite a few people to try to get on the same page. So we've been trying to enhance metadata guidance for platform and instrument. We have initiated discussions with colleagues in the IU's program office about updating metadata guidance to try to make it as clear as possible and as easy as possible to be followed by the data providers and the DACs. We also provided feedback to the National Glider DAC about common issues describing platform and instrument metadata. Just touching a little bit on something that John mentioned. John, I think it was John, that mentioned that best practices change over time, or maybe it was Kristen. Data management best practices do change over time. So we are, the types of instruments also change over time, so different items change over time. So we're trying to figure out what would be the best way to document that. And we just had the session about updating the ACDD on Tuesday. And then that was brought up that, okay, people have a way of doing things, and now we're trying to improve that. And of course, there's a little bit of hesitancy depending on the group to get it to do the best practices, the updated best practices. So we're trying to make it as easy as possible for the groups to conform to that. Next, please. So besides all those items, we're also facilitating the archiving of IU's data sets that have not yet been archived at NCEI. And as part of that effort, we meet with and collect information from data providers. We evaluate metadata and provide guidance, as we've mentioned before. There's also quite a bit of documenting standard operating procedures and working on the automation scripts. Again, as best practices change, sometimes those scripts need to be edited, need to be changed a little bit to improve something or fix something. Next. All right, so that was it. That's what I had to say for today. Please let us know if you have any questions on Slido or maybe in the chat. And also, we were just wondering if anybody would like to comment on these issues that were raised and if something similar happens in your organizations. Thank you.
Thanks, Anna. Yeah, I guess while people are mulling over, our second question, our question here, we do have a question in the chat, I believe, for us. So, and I'll ask it, and we can see which of us wants to answer. So, do all parameters measured by IU's platforms have CF standard names? And it sounds like this is not actually true for all meteorological and ocean parameters.
I think the answer is no. And in fact, is it GCOOS that's been working with CF to define a new name for one of their? Yeah. So one of the RAs is working with CF to define a new standard name and get approval for that, and because they did exactly what I think, was it Anna who mentioned, or was it Kristen who said, they made up a standard name. They made up a standard name, yes, and use that in their data files. And so that causes issues. No, CF doesn't do everything, but of course the guidance is that if there is no CF name, you use alternate documentation. The long name attribute in this case is usually what you're supposed to use instead to describe the variable. Andrew, go ahead.
I have a lot of involvement with CF, and we're pretty much all volunteer there. And so if anyone getting involved and helping out with managing the standard names is something anyone here can do. So, it's so kind of pitching that a little bit. And then also I can straight answer, no, not every variable has a CF standard name. And I have also seen made up variables in the Argo data set of all places. I was standard name, sorry. And I was quite shocked.
And that reminds me of something we talked about a little bit in the ACDD session earlier this week, is that, the documentation for how to use the NCEI NetCDF templates and the IUS metadata profile and ACDD as part of those, all of that's great, but there's so many things you can do, and there's only so much time you have. So how do you make the decision which of those is the most important for either your community, for long-term use and understanding, for whatever purpose whatever use case you have, and that's something that I don't think that that every organization has answered necessarily or thought about. S.R. Smith.
Yeah, I was actually realizing I hadn't changed my name again. This is Sean Smith.
Sean.
So related to that is going back to the earlier presentation where you had a workflow where you were checking CF standard names and then deciding whether you were going to do something with that data. Do those data get lost? Are they getting archived if they don't have a CF standard name?
The short answer is it depends. The longer answer is it depends on which data set you're talking about. I hope you can't hear my dog barking. Some, as was mentioned earlier, some data sets we are very strict about archiving data that doesn't have valid CF names. Other data sets, we accept that vagary of data management practice and archive the data as is. And it really just depends on the agreement with the data provider, and also how much effort the organization is willing to spend to react to these vagaries in the data. Now that we have Kristen and Anna on board, we have a little more resource we can apply to the question and work with the data providers to try to improve their data management practice. But some data we get what we get, and we've had little luck having improvements made at the data provider side, and so we will generally just archive those and accept the fact that they might cause somebody trouble down the line, but at least they've got the data. Are there other questions, or do either of you wish to add anything to that?
Not really. It's very much of a gray area. So we do our best to enhance things, to improve things, and it depends on. So last year we really wanted some groups to make sure that they had all correct standard names, all valid standard names, and then they were on mission critical funding, so they had a hard time allocating time and folks to actually do that work. So it depends on how funding is, and depends on the time availability of the people involved. It depends on a lot. So it would be great if, hypothetically speaking, we said no, only with valid standard names, but we don't think it would be wise to do that.
Any other questions in Slido?
I don't see any related to our talk. I mean, I guess just more generally to add on to that, we have been, thinking about or trying to think about ways or things, that we can control. Like we can provide guidance, or we can try to provide, like a Python script template to generate a netcdf file. And try to, I guess, lower the barriers to having more compliant files. But of course, we can't account for everything, and yeah. So it's a tricky balance.
Peng?
Yeah. Follow on to the previous CF's complaint. Are you define what to complain, or just the complaint to CF if the field is filled basically the way of asking question is when you have that CF compliance requirement, do you actually define the minimal fields you like them to have? Because sometimes when you run the CF checkers, it only check if it exists, does it comply to CF? So I can not have anything, it may still pass because I don't have anything for you to check.
Yeah, that's an excellent question, Peng. That's something we haven't put as much time into, and please correct me if you disagree, Kristen and Anna. We definitely spent more time just trying to figure out if the data that we are getting complies at the lowest level. Trying to do an analysis of the actual variables and find if there are CF standard names that should be used because that variable happens to match that description. Yeah, we have not done as much of that, if any. But that's a really good point too. I think the guidance says that you should use the CF name if it applies, but you know the guidance is the guidance, and we know how well it's followed.
Thanks.
Thank you, Peng, for your question. Any other questions in Slido or here in real life?
We do have other Slido questions. I think maybe more related to the first talk, so I guess I'll just jump into those. I guess the first one is, how do the open data licenses impact NOAA commercial data buys?
Tyler, do you want to talk about that at all, or Inger?
Yeah, I can handle that one. So currently, our guidance would say that we wouldn't put a CC0 license on commercial data that we've acquired under some kind of an agreement with a provider. Our current CC0 guidance is only for data that we've collected ourselves and from our own observing systems. To my knowledge, the agreements that we have for acquiring commercial data right now don't include a license, but in the future, that is something that we'll be trying to roll into. So from the beginning conversations, when we start to acquire data from a commercial source or from any source, as John was talking about with anybody who's providing data to NOAA, we will start to ask them to put a license, a formal license on that data, so that we then know what our requirements are, for what we are able to do with the data ourselves, and whether we're allowed to share it externally, whether what uses are allowed on that data. So it's not something that we currently take into account with the commercial data, just because that wasn't part of our thinking when we wrote those agreements. But in the future, we will definitely be making sure that any data that we acquire, commercial or otherwise, will have a formal license on it.
I should mention also that the NOAA Office of Coast Survey has been doing this kind of license tracking for their data buys for a long time. So Sorry, my dog is barking. Can you hear that? So that they track the license that applies to every buy and which license applies to the NOAA collected data. And they can document every piece of data in the system. And we hope to do the same for similar products at NOAA in the future.
Well, we've got another question. What persistent identifiers have you considered for funding sources?
Jen Fagan in the audience? I actually can't remember. I know Sarah O'Connor. Oh, there we go. Sarah O'Connor says FAIN or DOI are the current proposed PIDs for funding sources, funding vehicles. But that decision is still under deliberation.
Hey, this is Jessica. So I've been working with Jen Fagan on this, and I think she might have had to drop out of this session. So the idea is to leverage existing information that is routinely put out into the public. So you should all be aware of usaspending.gov, right? And they literally, for every grant award, there is a landing page that updates annually that shows you all the information, the public information about that award. And so what our PIDS officer, let's call her Jen Fagan, is kind of thinking of is leveraging the existence of that with the technology and the data site license that we have to ensure that for our funding, we have a sustainable and consistent and maybe intergovernmental way to create a persistent identifier that will always point to consistent information that is sort of auto-generated from the grants. And that is as far as I know today.
Well, thanks, Jessica. And I should mention that for those of you who need to know, that Jessica is the NESDIS Assistant Chief Data Officer, and so she's very interested in questions like this. Are there other questions, Kristen?
Yeah. The next one is, will you talk about gold standard science? How does that touch NOAA data centers?
Yeah, so I'll take this one since I was the one that made the mistake of mentioning gold standard science. This is really an emerging topic at NOAA. We are really working on defining how we'll need to change or document or adapt our processes to make sure that we can show that we're meeting the requirements of that gold standard science executive order. I mean, obviously, we feel very comfortable that the science that we do is of high quality, but it's just a matter of documenting it in a way that shows that we're meeting those gold standard science requirements. This is, as I said, an emerging topic. So we are working with federal partners on figuring out how we need to respond. And I very much think that this is something that's going to come up in the ESIP summer meeting. So stay tuned for that.
Thanks, Tyler.
Okay, and we have one more question, at least currently. And this, I think it relates to potentially the one of the previous sessions, but how does NESDIS, which I believe is NASA, so NASA Earth Science Data and Information System, NESDIS, relate to NESDIS, the NOAA National Environmental Satellite Data and Information Service, if at all? How are they related?
Yeah, that is a very good question. Do you want to start, John?
Well, as you might guess from their names, they have very similar missions. We have a lot of relationships between NOAA, specifically NESDIS, and NASA. We work together on a lot of projects. I think we even share some software. The CMR, Common Metadata Repository, is deployed both at NOAA and NASA. But I don't know how much real sharing there is of like staff and code, that sort of thing. Tyler, do you have anything to add?
Yeah, a couple things. So first of all, the kind of the purpose of the NESDIS satellites and the NASA satellites is just, it's subtly different. So our job is to be the opposite of cutting edge in a way, where our job is continuity. So if you're running operational weather models and trying to predict the weather, you need an absolutely consistent, predictable, constant flow of continuous data. You need to measure exactly the same thing, maybe with slightly higher quality with each satellite, or some subtle differences, but the whole point is continuity. And we do a lot of planning to make sure that we're going to have continuous coverage and redundant coverage of these very important parameters that come from the NOAA weather satellites. And then the NASA missions are more cutting edge and not proof of concept. It's more than proof of concept, but they don't have that same expectation of continuity, basically. So their job is to be forward looking and be kind of innovative in a way that doesn't meet the NOAA mission. So there's it's kind of a subtle distinction between what NASA expects from its satellites and what NOAA expects from its satellites. But from a data perspective, we also work very, very closely with NASA on developing and building and launching all of the satellites. So from a satellite development perspective, we're like lockstep, hand in hand. But from a data perspective, we measure a lot of the same parameters, and a lot of the data can be used in conjunction. And we have active collaboration with NASA on how we can make our systems a little more harmonious and a little easier to use those data more seamlessly, let's just say. Yep.
And we have
a Venn diagram would be great. Yes, I agree. Thanks.
Thanks, Amy. We have, of course, worked very closely with NASA on different projects such as GRIST, and so that has a common data standard that we both implement, and there are connections between NASA and NOAA discovery systems, and we've worked pretty closely with NASA to keep those connections working. Did I see a hand up?
Yeah.
Head Anna.
Yeah, I lifted and then I lowered and then lift again. I'm not really sure. So is there any intersection when we're talking about data sets? So it's totally separate data sets for NESDIS and ESDIS, or there are some data sets that are in both?
Well, it depends how you define that, because the data are coming from the same satellites, but the products that are generated are separate products, either NOAA or NASA products. And but Peng, did you want to say something to that? Seem to have lost her.
I turned the video on. So Ken might be a better person to answer this particular question, but in the Earth Data Search Portal, which is the portal for the ESDS, that's the NASA Earth Science Data Information System data holdings, and does include a lot of data sets from NOAA. At the same time, and NOAA climate data records do have a data set that's created by mature NASA algorithm that's produced by NASA producers. So I definitely see a lot of collaboration and the tight relationship between the two.
Thanks, Peng. And of course, we we talk to our NASA partners a lot, and we both help fund ESIP. So there's this arena as well.
Yeah, it's definitely a lot of challenges and needs for both systems. Okay, Ken said he can try to answer some of this. Go
yeah,
for
can
it.
you guys hear me?
Yes, Ken.
Okay, great. Yeah, I had some glitches here. Sorry.
Yeah, the question was NESDIS and NESDIS are very similarly named. What's the intersection between the two? Okay.
Yeah. And I saw the comment there about a Venn diagram. So they don't really have any overlap organizationally, right? ESDIS is entirely part of NASA, and NESDIS is entirely part of NOAA. However, we collaborate very closely, and over the years, particularly under the international umbrella of CEOS, the Committee on Earth Observing Satellites, we spent a number of years, probably 5 or so, sharing our metadata with the folks in ESDIS so they could load it into their version of the CMR and therefore enable sort of this internationally, collaboration, more common data discovery. And that collaboration involved other agencies and other space agencies around the world as well. So you were able to search through the NASA tools for data that resided elsewhere, including at NOAA. There were a lot of problems with that. It was never quite perfect. We struggled mightily to really get the CMR to, kind of accommodate the complexity of our NOAA metadata, given all the much greater data and metadata diversity that we had. Now, more recently, and I think I heard some conversation about this as well, over the last couple of years, we've been installing the NASA CMR within our NESDIS Common Cloud framework as well, with the idea that then those, like our version of the CMR and the NASA version of the CMR, it would just make it a little bit more interoperable for users. If you already know how to search the NASA CMR API endpoint, you'd be able to do the same thing on the NESDIS one. So that's sort of kind of the goal of it. But it's I'm trying to read the chat here too. But we've just recently in the last week within NESDIS really decided to kind of narrow the focus of our CMR implementation, really kind of keeping it very limited to like the NESDIS satellite products. And eventually by the end of the fiscal year, I think our goal is to have the NESDIS CMR API available publicly, but we won't try to put all of our metadata into it. We're moving away from that idea and instead still relying on the one-stop inventory manager, which provides our entire NOAA, NOAA-wide, not just NESDIS-wide data discovery. I hope that helps a little bit.
Thanks, Ken. While we are rapidly reaching the end of our allotted time, are there any last minute questions? I see a comment from Peng saying the ESIP Data Stewardship Committee is focusing on cross-organizational interoperability. Keep up the good work. All right, hearing no last questions, I will say thank you very much to our speakers, Kristen, Anna, and Inger, and of course, Tyler, my partner in crime here, session chairs. And thank you very much to our ESIP fellows for their help making sure that this session ran smoothly technically. And thank you all for participating and listening and asking your questions. And keep those questions coming. We can talk about them next time. Have a great evening.